here we will study about the integration using the trigonometric identities. Now I will share my screen. Ma'am, my screen is visible, right, ma'am?
Yes, sir, it is visible.
Okay. So here, how to integrate. First, we need to know what is an integrand and why these trigonometry identities are important for finding the integral. So that is a very important. So now I will use the whiteboard first. After that, I will come to the PowerPoint. So we know some identities here first integral. So if I'm taking this f of x, integrating f of x with respect to x, we know what is a integrand. This is called the integrand. So whenever this integrand involves a trigonometry function, then that time how we can find this integral value. That is a very important. Suppose if it is a polynomial, we know it is easy to evaluate this integral. So whenever this f of x is a polynomial kind of function, then we can find this integral value easily. But the suppose this integrand involves trigonometry terms, then how we can find the integral? That is a today topic. So it is a interesting one because here we need to know many trigonometry identities for evaluating this integral. Here whiteboard is visible to everyone, right? This whiteboard.
Yes.
Okay.
Students, if you have to communicate anything, you can type it in the chat box.
So here today our topic is suppose the f of x is a trigonometry function, how to evaluate. But before going that content, we need to know some trigonometry identities. For example, we know sin square theta plus cos square theta equal to 1. So this is an important identity because we can use this identity many places we need to use. After that, we know secant square theta minus tan square theta equal to 1. Even cosecant square theta minus cot square theta equal to 1. So these are the everyone we know these identities. Not only this, we need to know some other identities also. So here mainly I want to talk about the where the even function, odd function that I need to tell here. So first I am taking the this plane. So this is a first quadrant, everyone know. So here all functions here, sine function, cosine, secant, all functions are positive. That means we will get only positive value. This is actually we can tell all silver key. So here actually this is a 90 minus theta. This one is a 90 plus theta. The theta is an angle, or otherwise we can say 80 minus theta. So here 270 minus theta, or otherwise 180 plus theta. So here we know this is a 270 plus theta. Here otherwise we can say 360 minus theta. So we have 4 quadrants. In the first quadrant, all the trigonometry functions are positive. The second quadrant, only sine function and cosecant function. The third quadrant, this is a tan. tan only positive. So in the fourth quadrant, cosine function is a positive. So this is a very important. So easily you can understand. So this is simple way, all silver teacups. So this is a way. So we know already sine function is a sine of minus theta is a minus sine theta. This is a odd function. Next one is cos of minus theta. This is a cos theta. Cos theta is a even function. So similarly, we can write tan of minus theta is a minus tan theta, right? So because we know tan theta is sine theta by cos theta. So similarly, this sine of minus theta is minus sine theta. So cosecant of minus theta is also minus cosecant theta. And secant of minus theta is equal to minus, this is a plus because secant is a 1 by cos. So therefore, this is a secant theta. And even cot theta is a 1 by tan theta. So cot of minus theta is also minus cot theta. So these are we need to know because some identities it is a very important. So that first we need to know identities. After that we can go for the evaluation of the integral. So next one, here not only this, in this quadrant, how we can write it, that sine of 90 minus theta, cos of 90 minus theta, that everything we need. So first I will take here, we can take this one, sine of 1 minute. Yeah, sine of 90 minus theta. This is a sine of 90 minus theta. This is in the first quadrant. First quadrant, we know all the functions are positive. But this is a cos theta, and cos of 90 minus theta. This is equal to sine theta. These identities are very simple one. Easily we can identify these things. And tan of 90 minus theta is equal to cot theta. So because here you see all the values are positive values here, because in the first quadrant here it's a positive, all kind of function, not only sine cos, even we can write cosecant of 90 minus theta is equal to secant theta. So secant of 90 minus theta is nothing but cosecant theta. Even cot of 90 minus theta also we can write this is a tan theta. So these are very simple identities. So here I think we won't get any doubt. So next also in the second quadrant we can write 180 minus theta, or otherwise sine 90 plus theta we can write. So that is also here what we can say. It's a very simple identities, but these identities we need to use for evaluating the integral. So here the next one is here sine of in the second quadrant 180 minus theta. But you know in the second quadrant sine function only positive. So this is sine theta, and here cos of 180 minus theta, this is a minus cos theta. So next one, in similarly we can write tan and tan of 180 minus theta. These are these already I gave in the PowerPoint presentation. So this is nothing but minus tan theta. Because why I am telling, you need to know in the second quadrant only the sine function is a positive 1, or otherwise here we can write cosecant theta, that is 180 minus theta, that also cosecant theta, because we know 1 by sine is nothing but a cosecant theta. So these things are very important. So, but not only this, we have some other formula, some other identities, trigonometry identities, that also you need to know. For example, there are some identities here I want to mention. So these things are very simple, even in the 11th, 10th standard, you studied already these things. So now I am coming to some identity, important identity, sine of a plus b. The sine of a plus b, we can write it sine a cos b plus after that the sine a cos b cos a sin b. So these are the important identity. Sin a minus b, we can write this is sin a cos b minus cos a sin b. And this identity and this one and another one, cos of a minus b or a plus b. So cos of a plus b is nothing but cos a cos b. Here it's a minus will come, sin a sin b. So then next identity, another one more identity is here. That identity is cos a minus b. So that we can write cos of a minus b, this equal to cos a cos b plus sin a sin b. So here we not only this sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b. So from this we can identify product of two trigonometric function also. So now I am coming to the whiteboard. Now in this whiteboard already I have mentioned some important things. So here the symbol, this is already I mentioned, this f of x is called a integrand, and this is nothing but a integral of f of x with respect to x. So this f of x is nothing but a integrand. Here the variable of integration, that x is nothing but a variable of integration. Integrate means we need to evaluate the integral. So that is a very important one. Integration means the process of finding the integral. So these things are already we know reciprocal of trigonometry identities. Here sin theta is 1 by cosecant theta, and cosecant theta is 1 by sin theta. These are already I told. So here these identities are very important identities. This also we need to know because this we will use in the evaluate in the finding in the integrand. We want to use this trigonometry identities. So under the trigonometry ratio identities, this is a well-known one. Tan theta is sin theta by cos theta. Even we can prove via geometrically also, but that is not needed now because these are already well-known one. So these things already I already explained this list of opposite angle trigonometry identities. So the next one, this also because this is in the first quadrant. In the first quadrant, we know all the terms are positive. You see, sine of 90 minus theta, cos of 90 minus theta, sin theta. Here, this is in the first quadrant. First quadrant, all kind of functions, we will get the positive one. So this is in second quadrant. You see, in the second quadrant, 180 minus theta. So only sine function and that cosecant functions are positive. Here you see here. So this already I explained it. So the next one, this is a I mentioned in the whiteboard also. Sine of a plus b is sine a cos b plus cos a sin b, and sine of a minus b, sine of a into cos b minus cos a into sin b. So these are important identities. even we have geometrical, we can prove via geometrically or theoretically. So, and these identities also important, tan of a plus b, tan of a minus b. So these are the well-known identity, trigonometry identities. So you see, this is a very important function, sine 2 theta. Sine 2 theta, we can write it 2 sine theta into cos theta. So, but cos 2 theta, this cos 2 theta is nothing but cos square theta minus sine square theta. We know what is a cos square theta. So we can write this form also, or otherwise we can write in this form. So, but mainly we need to know this formula. From this, we can rewrite this terms like this: 2 cos square theta minus 1 or 1 minus sine square theta minus 1, because we know cos square theta plus sine square theta equal to 1. That maybe I can explain via whiteboard. So this identities are very important in the evaluation of integral, so that we can use it later. But now that sine of 2 theta, 1 minute. Yeah. So here already this one everyone know, sine 2 theta, this equal to 2 into sine theta into cos theta. This is a important one identity, important identity. So cos 2 theta we can write cos square theta minus sine square theta. So this identity we can rewrite into two forms. That one is, we already know what we know. Here cos square theta plus sine square theta is equal to 1. So from that, this we can rewrite this. Cos square theta is nothing but 1 minus sine square theta. That is, here cos square theta is nothing but 1 minus sine square theta. So if you are substituting 1 minus sine square theta, you will get 1 minus 2 sine square theta. Or otherwise we can write in another form also. So another form, how we can write this equal to 2 cos square theta minus 1. So these are equal, because here we will fix cos square theta. We can rewrite sine square theta is 1 minus cos square theta. So we will get 2 cos square theta minus 1. So these identities are very important for us, if because mostly these identities we will use in the integration. So the next some other formula also very important here. So tan 2 theta formula, because we can evaluate from sine 2 theta by cos 2 theta. So from that we can take LCM and we can evaluate this one. And half angle identities. So these are very important one. The next one, product sum, that is a some other identity. So these identities are very important. We don't want to prove, but we need to know, because in the integration time we need to use these identities. And mainly we know cos a minus b, cos a plus b. So if you are cos a minus b minus cos a plus b, we will get 2 sin a into sin b. Similarly, sin a plus b plus sin a minus b gives 2 into sin a. Just we need to add, already we need to know sin a plus b and sin a minus b. Just we need to add that 2. So we will get 2 into sin a into cos b. So similarly here cos a plus b minus cos a minus b is nothing but 2 into cos a into cos b. So these are important identities. Now we will come to the integration part, because first we need to know what are the identities, what are the important identities. That is a very important, because that if you know the trigonometry identities, then only we can evaluate the integral if the integrand involves the trigonometry terms. So that is a main important one. So the first question, just a very simple one, first problem, I will take very simple one. For example, I am taking one. So first, I will take very simple problem here. So here you see, I am taking sin x into cos x dx. So now we see, you see this f of x involves sine function and cosine function. But if you know the identities, easily we can evaluate this integral. Otherwise, it is a very difficult. So we can't write this series expansion sin x cos x also. It will take lot of time. So here, if you know the trigonometry identities, for example, what trigonometry identities here we can use, that is a very important. So we know what we know, sin 2 theta equal to 2 into sin theta into cos theta. So if you know this trigonometry identity, this integral is very easy because easily we can evaluate this integral. So here sin 2 theta divided by 2 is nothing but sin theta into cos theta. Just so this is nothing but sin 2 theta by 2. So that so therefore the given interval we can rewrite sin 2 theta by 2. So this is nothing but 1 by 4 into minus cos 2 theta plus c. So you see, so here this to this, how to rewrite, that is a very important, because if you don't suppose in case we don't know this identity, then the this integral is easily we can't find, because only if you know the trigonometry identities, directly we can evaluate the integrand that integral value. Otherwise, it is a very difficult. So the next another one example I will take. So that is a simple example. For example, integral of cos square theta or sin square theta we can take. So here integral of cos square theta, or otherwise we can take integral of sin square theta. So sometimes the product terms will come, sometimes power functions will involve. So here, suppose cos square theta is coming. We know already one formula for cos square theta. So cos 2 theta is nothing but 2 into cos square theta minus 1. So from this, we can evaluate cos square theta. So cos square theta is nothing but 1 plus cos 2 theta divided by 2. So if you know this identity, then this integral easily we can evaluate. Otherwise, it is a problem. So here we can directly we can substitute. So this integral we can rewrite. This is equal to 1 plus cos 2 theta divided by 2 into this into with respect to theta. So this is nothing but 1 by 2 theta plus sin 2 theta divided by 4 plus c. So this value. Similarly, you can evaluate this also, because I will give you how to evaluate this just idea. This sin square theta, because we know cos 2 theta is equal to cos 2 theta is equal to 1 minus 2 sin square theta. Just you need to use this trigonometry identity to evaluate this integral. So from this, I just gave only two simple examples. So we will see, we will solve some other examples also. So from this, if you have any doubt or any clarification or any question, that are always welcome. So in your side, any questions or doubts, please ask here. I am ready to explain or ready to clarify your doubts. Please, any questions or any doubts or any clarifications? Sorry, in the first question, what if you take sin x as a t and the cos x is, sorry, what if you take sin x as a t under cos x dx. Yeah, you can use some other way also. This is a one way, because whenever if you know the trigonometry identities, you can solve the problem easily. Otherwise, we can use some partial fraction, or here mostly we can use some substitution way also to evaluate the integral. So not only, because here if you know the trigonometry identities, how to evaluate the integral. When the integrand involves the trigonometry function, then additionally you need to know trigonometry identities, then how to evaluate the integral. Otherwise, you can use substitution also. Maybe I will tell you some other substitution way also. For example, I will take some other problem. So the next problem here, this examples already here I have mentioned. So integral of cos square x dx. So only we need to know cos 2x formula. If you know the cos 2x identity, then we can rewrite cos square x equal to 1 plus cos 2x by 2. Just we are substituting here, and we are easily we can evaluate that integral value. So that is nothing but x by 2, 1 by 4 sine 2x plus c. So the next is sine cube x. Here you see, this is a very important. Here we can evaluate two ways also. One way, here integral of sine cube x dx. So you see here, we can rewrite this sine cube x like this, sine square x into sine x. But already here mostly what I am doing here, only I'm using the substitution. So u equal to cos x, and what about that? So this maybe I can evaluate via whiteboard. Then easily you can understand. So here sine cube x. So we need to use the trigonometry identities, or otherwise substitution also we can use. So this we can without trigonometry identity. Here also we need to use, but you see this we can write sine square x into sin x into the, so this we can, here we can use trigonometry identity, that is sin square x is nothing but 1 minus cos square x, this into sin x. So now I am assuming u equal to cos x. So then du by dx is nothing but minus sin x in sin x. So this we can rewrite du equal to minus sin x into dx. So you see here now we can substitute. So then the integral part is, so then this is integral over 1 minus u square, because I am substituting here. This is a cos square x is nothing but u. So this is sin x into this is already here we know. Here already we know this one. So if you are using this, here minus will come, minus into d. Right? So this evaluation is very easy. So now you see minus, so minus u into minus u plus u cube by 3 plus constant c, already we know what is a u, just you can substitute here minus u is already here, we assumed cos x, so then you need to substitute cos x plus cos cube x by 3 plus c. So this is one way. And another way, without this substitution also, we can directly evaluate this integral value. But how we can? Only you need to know sin 3x formula. So sin 3x is nothing but 3 sin x minus 4 sin cube x. Is it sin cube x? So from this, we can evaluate this sin cube x. So from this, we can evaluate sin cube x. If you are substituting here, we can evaluate without any substituent, we can evaluate this integral value. So we have many ways, but we need to know the shortest one, because the examination time, the time management is very important. Which identity we need to use to evaluate this integral, that is a very important. We have many ways, but if you know the identity, we can use directly this sin cube, we can compute from the sin 3x identity, then we can. So that also here I have, this is one way, this is already explained in this PowerPoint. Sin 3x, here we are taking u equal to cos x, and this also we know how it is coming, that already I explained it. So from this we can we are getting this one. So after that again we are substituting u equal to cos x, so then finally we are getting the same problem. Here you see, just I am using this identity, sin 3x identity already. This is a well-known identity. So from this we can identify sin cube x. So if you are, sin cube x is nothing but 3 sin x minus sin 3x by 4. So just we need to substitute, and we know the integral satisfies the linearity. So here that we are using. So within one step we are getting the answer. So compared to this one, this evaluation is very simple. When this sin 3x identity, if you know, then this evaluation is very easy. So we have many ways to identify or to evaluate the integral value, but mainly you need to know the identities, trigonometry identities. So without trigonometry identities, the evaluation of this type of integral is not easy. So here also, if you know the trigonometry identity, we can find in different way this integral value, but we will get same answer only. You see, you can use any way, but we will get final answer is the same answer only. So it won't change. So the next one. So here you see, here not a power, the trigonometry functions are not involving power terms, but this integral of sin 2x cos 3x with respect to x. But here we know some formula, right? So what formula we know? So here this problem is a different one. So because two different trigonometry, the product of trigonometry functions, not a power functions. So here we can take, this is a integral of sin 2x cos 3x, I think. Yeah, so this one is given. Only here we need to think what identity here we need to use. So depends on that only. We know many identity, sin 2x identity we know, cos 3x identity we know, but if you are using again the product term will come, so that we need to avoid. So then what we can do, we know sin a plus b, that is nothing but sin a cos b plus cos a sin b. And sin a minus b form also we know. So here sin A cos B minus cos A sin B. So this is one. This is a second equation. So if you are adding 1 plus 2, this gives what we can get, sine of A plus B, and we need to add sine of A minus B equal to 2 sine A cos B. So from this we can rewrite sine A cos B equal to sine of A plus B plus sine of A minus B divided by 2. So this is a main important identity. These identities are already available, but how we are getting this identity, that I explained here. So you need to know this sine of A plus B, sine of A minus B. From this we can rewrite, because here A is nothing but 2x, B is nothing but 3x. So now we can use this identity here. So easily you can evaluate this integral. Yeah. So here, so then here we can write this is integral over. So here sine of A plus B, A is 2x, B is 5x. So sine of 5x divided by 2 plus, and sine of A minus B. Sine of A minus B means you already know sine of minus theta is minus sine theta, because sine function is a odd function. So this is a very important one. Sine of minus theta equal to minus sine theta. So here what we can write, minus sine A minus B, that is x, divided by 2. So this is a with respect to. Here you have any doubt or any question, 1 by 2 is a common here. So sine 5x, sine 5 by 5x, so that is nothing but minus cos 5x divided by 5. Here already minus, in this is a minus involved here. So plus into minus, minus. So if you are integrating, integration of sine x is nothing but a minus cos x. So this plus cos x by cos x by 1 plus c. So this is a formula. You see, within 2 steps we got answer. So because of this identity. So whenever if you know the identities, trigonometry identities, the evaluation of the integral is easy if the integrand involves the trigonometry terms. So we need to know some trigonometry, some important trigonometry identities. We need to use the correct trigonometry identity here. Then within 2 or 3 steps, you will get the answer. So that is here. Already I have mentioned it. So this sin x into cos y equal to 1 by 2. So how we got this identity, that I explained via whiteboard. So integral over sine 2x cos 3x we can. So how we wrote here minus, that is a, because sine of minus x is a minus sine x. So that identity also you need to know. So then the integral is what about integral of sine x, what about integral of cos x, that everything you know. So we are getting finally this answer. So the next one here. So you see here product terms are coming, and additionally powers also coming. So product of 2 trigonometry function and the powers also involving, then how to evaluate. So this type of things are coming, then this is also easy if you know the trigonometry identity. So just again we will come to the whiteboard. So here how we can evaluate that a integral value, that is a here I will explain, because that is also easy, not a difficult one. So integral of sine cube x, I think cos square x. So here, so this we can rewrite. Here we can use some substitution because the product and powers are involving. So here this we can write sine square x, sin x, and additionally cos square x. And here we can use very simple trigonometry identities. This sine square x is we can rewrite cos square x, the sin x into cos square x. But already you know, here we can take u equal to cos x. So if you are taking u equal to cos x, this du by dx is nothing but minus sin x. So then this integral we can rewrite 1 minus u square. This is cos square is u square and sin x into, so this we can rewrite minus du equal to sin x. Just we need to substitute here. So this is nothing but minus of d. Then this is integral over u square minus u4. Here minus we can take out. So this is very easy. So minus u power 3 by 3 plus u power 5 by 5 plus c. Just you need to substitute u equal to cos x. So u equal to cos x means minus cos cube by x by 3 plus cos power 5 by x by 5 plus c. So then, so only here how to split these terms. So that is a very important. Just this substitution, if you know, we are using very simple identity with the substitution. So this, but you see, if you don't know this idea, then this integral evaluation of this integral is not easy. And additionally, I have mentioned some other, because here already we know minus cos square x, that same thing. So this we know. This maybe it's a practice problem. Maybe you note this one. So integral of sine inverse cos x and integral of tan power 4x and this. But here you need to use the correct identity, then easily you will get within 2 or 3 steps answer. So in the next one, so we saw one problem, right? So the product and the powers are involving, then how to, you see here. So here, which one is odd one that you need to identify? So sine 4x, sine power 4x, this is a even power, this is a odd power. So we need to split this odd power tape. So that means cos square x into cos x. But already you know that cos square x, that is 1 minus sine square x. So 1 minus sine square x into cos x. Now you need to take u equal to sine x. So in the previous problem also, we are taking what we are taking u equal to cos x. But in the previous problem, you see odd powers are coming here, sine cube x. So sine cube x only we are splitting into sine square x into sine x. But here in this problem, cos cube x. So here we don't want to change anything in the even power term. So only odd power term we are rewriting, that is cos square x into cos x. So cos square x, we know one simple identity, that is 1 minus sine square x. Then easily we can evaluate. You see here, just you need to take u equal to sine x, then du by dx is nothing but a cos x. So then we can just we need to evaluate this value and we need to again resubstitute equal to sin x, then you will get it. So only the trick you need to know, because very simple identity, this identity cos square x plus sin square x equal to 1, but where we need to use, why we didn't use here. So you don't need to touch the odd even power term. So only you need to rewrite the odd power term. Then we can use this simple identity. Then we can evaluate this integral value. Then easily we will get. And not only this term. For example, I will take some other different integral. This maybe we can how we can evaluate using the trigonometry identity. So if you know trigonometry identity, the evaluation of the integral is easy because within 2 or 3 steps you will get the answer. So here the another additional one. So the here integrand involves the trigonometry, but integrals not involves the trigonometry. There also we can use trigonometry identities. For example, this is a one example, familiar one, u square du. So we need to evaluate this integral, but you see this is a 1 by 1 plus u square, but we don't know how to evaluate. So here you can take u equal to tan theta. So du equal to du by d theta equal to secant square theta. So just you need to substitute here. So this integral we can rewrite 1 plus this u is nothing but a tan square theta. This now this we can rewrite secant square theta into, just you can substitute here. You see it. This integral 1 by this 1 plus tan square theta is nothing but a secant square theta. So this also secant square theta d theta. So this we can evaluate. This is nothing but d theta. So this is nothing but theta plus c. But here what we assumed here equal to tan theta. So u equal to tan theta, then this we can rewrite. This we can rewrite. Theta is nothing but tan inverse of u, right? So here this is nothing but tan inverse of u plus c. So you see, in generally this integral evaluation is not easy, but only here we are using some trigonometry identities to evaluate this integral. So this integral evaluation is very easy if you know the trigonometry identities. Otherwise, this evaluation is not easy. So in a similar way, so this is one way. Suppose here some constant I am taking, integral of 1 by a square plus u square. That, so that 1 minute I will. So this everything PowerPoint presentation I gave, but you need to know the tricks and tricks and idea. That's only I'm using this whiteboard u square. So here we need to take u equal to, because the previous here a equal to 1, but here this is a more generalization. So here a into tan theta you need to take. So then du by theta equal to a into secant square theta. So then from this we can get d equal to a into secant square theta into d theta. So then this given integral we can substitute 1 by a square plus a square into, why we are considered here a, because we need to take this a square out, because here this term involving a square, this term also if it is involves a square, then easily we can eliminate. So for that reason only here I'm taking this one, a square into tan square theta. Here this is nothing but here we already evaluated a into secant square theta. So here integral of, here a square is common, 1 plus tan square theta, right? This is a tan square theta, this is plus tan square theta, and here a into secant square theta. So this is nothing but integral of 1 by a. So 1 by a we can take, this is secant square theta, a here secant square theta d theta. So this getting cancelled. So 1 by a into theta plus c will come, but from this we will get theta is nothing but u by a equal to tan theta. So this gives theta equal to tan inverse of u by a. So then we can substitute here 1 by a into tan inverse of u by a plus c. So here this type of integral, if you are using the trigonometry identities, then we will get easily answer. Otherwise, it's difficult to find the answer. So that are here given, you see. So here, this I already explained. So integrals which make use of the trigonometry substitution. So x equal to tan theta, and here just we are substituting and rewriting how we are getting these terms, and additionally this integral of 1 by a square plus x square. So here also just if we are using the trigonometry substitution, then easily we can evaluate the integral, that integral value. So whenever the integrand involves trigonometry functions, we need to know some trigonometry identity, because we can solve not only in this way, we can solve many ways this problem and the other problem also. But we need to identify the correct trigonometry identity here. So otherwise it will take time. So because if you are writing the competitive exam, or if you are writing the school exams, annual exams, you need to know which identity we need to use, you need to know. Without practice, you can't get the idea. So you need to do practice, then only you will get idea. Otherwise, it's very difficult to find the integration. So any questions or doubts? I think some students, if in your side any questions or doubts or any clarification you need to ask, I'm ready to clarify your doubts and your questions also.
So students, if you have any doubts regarding this portion, you can type it in the chat box, or if you want to speak with the faculty, you can ask for that permission also.
No, actually, if you are using different formulas, you won't get a different solution. The solution of the problem is a unique. It won't change. You can use any type of identities. It's not a problem, but you will get a same answer only. We have many ways to identify or to find the integral value, but all the students need to get a same answer, need to get same answer. Otherwise, your evaluation is wrong. That is important. So in this for this problem, that integral of sin x or sin x cos x, so this kind of problems you will get only unique answer, not a different answer. You can use any different kind of steps or any different kind of formulas or identities. It is not a problem. But you finally you need to get the same answer only. So here one student Samyukta writes are different formulas gives different solution. That is the sum can be done by with the different solution. How do we know in competitive exam that a particular solution we need to use a particular formula? No, actually you will get a only unique answer only. But if you are did in the any mistake in the evaluation, you won't get a correct answer. So you can that's only that example two you see in the example two. So the first procedure is a different. You see in this example two, sine cube x. But sine cube x, I am writing sine square x into sine x. But here I am using entirely different substitution, different identity. But if I'm using this identity and this substitution, I think I need to do at least 3 to 4 steps to evaluate the integral. One step, second step, third step. This is a final one. So here I am getting minus cos x plus 1 by 3 cos 3x plus c, right? But here also, if you are identifying this formula, we can rewrite, because in competitive exams, what you will get some options, A, B, C, 4 options will come. But you need to, after that, you need to substitute some trigonometry formula to match that option. Otherwise, because the answers are unique only, but here, for example, some students will get sine 2x. Some students will get 2 into sine x cos x. But you need to know some, that's only I presented some trigonometry identities. That are the important identities. If you know that identities, easily we can match the answer to that option. Otherwise, it is a problem. So that is a important. So we will get it. So because here you see, here I am getting cos 3x something, here cos cube x. Just we need to substitute this cos cube x or otherwise cos 3x formula. If you know, then it will match. Otherwise, it's a problem. That's only that basic identities. If you know, then easily you can match to the option. Otherwise, it is a difficult. So, but the answer is same only. But only here sine 3x is coming, sine cube x is coming. So just we need to use some identities, then we can easily match the answer. But you will get only unique answer, not a different answer. So that is a one important thing. And
sir, there is one question from Google Raj.
Yes, ma'am.
Especially in using substitution method, cos theta power 3 is written as cos 3 theta. So he's having doubt in that.
Okay. So in yeah, yes, ma'am. That is already I explained it. I think especially in using substitution method. Yeah, yes. So here in this substitution method, that is example 2, they are asking the questions actually. Here 1 minute. This is example. So here only it's a problem is coming, because here 1 by 12 is coming, here 1 by 3, but cos 3x, here cos cube x. So we know cos cube x formula. Otherwise, we know already cos 3x formula. Just you can substitute here cos 3x formula, that this solution reduces to this form. So this both are same only. Just you need to substitute cos 3x. Then this time also will change. So these both answers are correct only. But here cos 3x formula, you see here sin 3x involves sin cube x. Similarly, cos 3x is nothing but cos 3x is nothing but 4 cos cube x minus 3 cos x. That just you need to substitute here. Both answer you will get same only. Just that's only what I told. You can use any method to evaluate the integral value, but you will get one answer. That answer we need to match with the giving, because they will give 4 options. We need to match at least one option. Multiple question is given in the competitive exam. Then if you know the trigonometry identities, then only you can match, otherwise you won't match it. But we either you can use this method or this method, it's not a problem, but mainly you need to know trigonometry identities, then only you can select the correct option, otherwise it is a difficult one only.
Sir, actually one student is asking permission to talk, so I'm
Yes,
just allowing.
yeah. Yes.
So hi Google, you can unmute and you can talk with sir. Just try to unmute.
Sir, good evening, sir.
Good evening, Google.
Sir,
Yes, tell me.
Sir, in example 2, I have one doubt. I think previous slide, I think so, sir.
This one. This one, Google, is it visible
Sir,
to
previous slide, I think so, sir.
First one. Example,
yes.
example 4 or example 1. Actually, that is not 4.
No, sir, example 2, sir. In substituting method, you like that.
Yes,
sir.
Tell me.
Sir, in the third line, you put equal to minus u plus u cube divided by 3 plus c. And
here actually this is cos cube x will come actually.
Yes, sir.
Because u is cos x. Actually, in the whiteboard I used correctly, but here I think a small typo error actually.
Yes, sir.
Yeah. Thank you, Google. This is actually minus, because we need to substitute u equal to cos x, right? So this is 1/3 cos cube x. That power actually here small typo error. Google, any other questions or any doubts or
no,
any
sir, no, sir.
Thank you, Google. Thank you. So any other questions or doubts, if you have, please ask here. Thank you for that identified that one error.
So if you have any doubts, you can type it in the chat box. So I think almost all the questions are clear now for the students. So if you have anything, we'll wait for one more minute. Okay. So I think almost all the questions.
I think some student asked, one student, is there any questions regarding one substitution, like instead of 1 sin square x plus cos square x? Actually, if already 1 is given, then why we need to substitute sin square x plus cos square x? That is difficult, because integration of 1 is easily you can evaluate, but integration of sin square plus cos square, that is no use. And another one is, can the answer of the same question different from the method we use? Can the answer of the same question different? Actually, that is already I explained it. Sir, I have a doubt in a specific which I had tried solving before. Can you please solve that for me, sir? If I type the Q using definite integral as well. Sneha, actually, I don't understand your question. Maybe you can, if you are possible, you can talk here. You can ask here via audio, and integral 4 to 5x.
Sneha, I have given you permission to talk. You can talk.
Sneha, you can talk here.
Good evening, sir.
Yeah, yes, good evening.
Sir,
Yeah, yes, tell me.
I had a doubt in the specific question which I had tried before. Can you please try solving it for me?
Which one?
Sir, I had typed the question, sir. Integral 4 to pi x by 1 plus sin alpha sin x dx.
1 x by?
Integral 4 to pi.
No, actually you put here 4 to 5. That is a limit, right?
Yes, sir.
So lower limit is 4, upper limit is pi. What is the integrand?
X by 1 plus sin alpha sin x.
Sin alpha into sin x.
Yes, sir.
What is that x? What is alpha?
So this is only this much is the question, sir.
Actually, what I am asking you now, because here variable is, or the alpha is a constant or variable?
It should be a constant, sir.
Sin alpha is a, that alpha is a constant.
Yes, sir.
Okay, then here you need to use 1 plus sin alpha into sin x. Here you need to use some substitution, or otherwise you need to use that tan 2 theta formula, or otherwise sin 2 theta formula. I think that formula is available. Actually, I mentioned that formula or not. 1 minute, I will check. That formula types are available, but I will go my presentation here. Here 2 tan theta 1 minus tan square theta is coming. That is, I didn't mention that formula, but that formula, this kind of formula is available. Actually, in your question, that involves the terms. 1 minute. Again, I will check. Yeah. So this one, I think here only you need to use. So x is you take common out, and this 1 plus sin alpha into sin x, you have some formula 1 by 1 plus sin alpha into sin x, you have a formula that you need to check. So if you are using the trigonometry identities, you can evaluate that one. That is, I think you need to check some other identity. We have that type of identity. What type of 1 by? So this identity you need to whiteboard. Yeah. So only you need to check, because here we solved some different things. Whiteboard. Yeah. So here you need to use here 1 plus sin alpha sin x. This sin alpha sin x, we have some identity, because this is some sin of a plus b, sorry, cos of a plus b minus cos of a minus b divided by 2, something it will come. Then after that, just you need to avoid this 1 plus here. That is here we need to just you need to take LCM, and you need to use some identity here. This type of identity you need to use. That you need to check maybe, because this type of identities are available, like tan 2 theta is already available. That type of identities also, even I saw for sin 2 theta and cos 2 theta also, these type of identities are available. 1 by 1 plus some sin of alpha into sin x, like that it's available. That if you are checking, you will get easily you can evaluate that integral. Once you are using the correct identity, then easily we can substitute the limit. Limit is not a problem, because limit is coming or not, that is not a problem. Only here, what identity we need to use? You need to check this cos 2 theta formula also, sin 2 theta formula also. But in this, actually here I mentioned some basic formula. Cos 2 theta, we can write cos square theta minus sin square theta. That we can rewrite in this form also. So that you need to check. And additionally, here you need to use that cos of a plus b, I think minus cos of a minus b. So that type of formula here you need to use. After that, you can use this kind of formula. Then you will get it.
Okay, sir. I'll try by that method. Thank you.
Thank you.
So students, I have just typed my mail ID in the chat box. So if you have any doubts, and if you want it to be solved from our side, we'll solve and send it to you. So you can mail us the questions. So that is also completely fine. So we'll solve and get back to you.